EMADE is the Evolutionary Multi-Objective Algorithm Design Engine. It's designed to be a plug-and-play tool for researchers to input training data and receive classification or prediction algorithms optimized to their defined objectives. EMADE is built on the concept of evolutionary programming. Evolutionary programming is a method for optimizing algorithms using mechanisms inspired by the process of biological evolution. The evolutionary process begins with an initial population. The traits or genes of the initial population are generated randomly. In each generation, new individuals are created by mutating existing individuals or by crossover between two parent individuals. Fitness scores are determined based on how well each individual meets the defined objectives. Since the initial population is generated randomly, it may take several generations before individuals with a valid fitness score begin to appear in the population. To speed up this process, an individual with a good fitness score can be used as a seed in the initial population to jumpstart the evolutionary process. This method ensures that successful genes exist in the beginning of the population. The non-dominated front represents individuals that are the best for a particular ratio of the given objectives. The goal of the evolutionary process is to reduce the hypervolume, or area under this curve in 2 dimensions. This indicates an increase in overall success rates or accuracy. In this particular example, the 2 objectives were false negative rate and false positive rate. In EMADE, individuals exist as trees of classifiers and primitives. Data enters the tree at the bottom and is processed as it moves towards the top. At the very top of the tree, a final classification is made. To get EMADE up and running, navigate to the EMADE repo on GitHub. There you'll find directions on how to install the necessary packages that EMADE runs on, as well as installation instructions for Windows, Linux, and Mac. The parameters that EMADE will use to operate are established in the XML file. Here you'll indicate things like your Python path, EMADE path, as well as how EMADE can access your database, including the IP address, login info, and name of the database. You'll indicate which training and test files you're using for your data, as well as where those are located. You'll establish your objectives. In this example, we're using false positives, false negatives, as well as a number of elements. You'll tell EMADE which evaluation function you want to use. If you're running on a cluster, you'll indicate your grid engine parameters. You'll also establish your evolution parameters, like crossover functions, mutation functions, as well as your selection function. Once you've established all your parameters in the XML file, you'll need to generate a pickle file. This is the file that EMADE will use to start your master and your workers. Once you've generated your pickle file, it's time to start a master and some workers. You'll need 2 terminal windows open, navigated to the folder in which you have EMADE installed. We'll start by starting a master. You'll indicate which pickle file you're using, as well as the database IP address and login information that you want EMADE to use. You can use the R flag to reuse individuals that are in the database, or the NR flag to disregard those individuals and completely start fresh with a new population. Once the master is up and running, it'll generate the initial population and let us know how many elements are remaining in the queue. It'll continue to do this in a loop, letting us know which year or generation we're on and how many elements are remaining in the queue. It'll keep doing this until we start some workers to pull those individuals. So let's go ahead and start some workers. Just like we did with the master, we'll indicate which pickle file we're using, as well as how many workers we want to start. We're going to go with 2 for now. We'll indicate which database information we want EMADE to use and hit enter. Once the workers have started, they will each pull 50 individuals to evaluate. As the workers start to pull individuals, you'll see that the master updates elements that are remaining in the queue. Now both of these will keep operating in a loop until either you stop the program or something crashes. Now, as you can see in our worker window, a lot of these individuals have an INF, basically an invalid fitness. This is because in the early generations, there may not be successful individuals that will generate a valid fitness score. Some other information that we can see in our worker window are the computing time for this particular individual, as well as its age. The goal of this process is to generate a non-dominated front. This is an example generated by the speech recognition subteam this semester. The red line represents a run of EMADE at the beginning of the semester. Over the semester, the team added a bunch of speech recognition primitives to EMADE and generated this blue curve. You can see the improvements that the new primitives made in the hypervolume or the overall accuracy of the curve. This is an example of a dominant individual produced by the speech recognition subteam this semester. You can see how primitives are passed into other classifiers and functions with a single learner at the top of the tree. We currently have subteams working on expanding the capabilities of EMADE. This includes speech recognition, stock price data, sentiment analysis, feature enhancement, and EMADE documentation. For detailed information on the automated algorithm design team's current progress, visit the team page at vip.gautech.edu.